So once the dot product of the vectors is 0, I can conclude that vector A is perpendicular to vector B. Mass into gravitational force into height up to which the water is lifted divided by the time taken. What is kinetic energy final minus initial? I know that kinetic energy is given by half mv square. This is final velocity minus half mv square. This is initial velocity. Hello students, welcome to this fourth session on work, energy and power. This is fifth chapter in your first PUC physics. I am Madhu R from the Department of Physics at Vidhyaashram PU College, Mysuru, your temple of excellence. This shall be a dedicated class on the numericals. Let us check them one by one. Show that vector A and vector B are perpendicular to each other. How do I know that two vectors are perpendicular? I can know that two vectors are perpendicular if their dot product is 0. Okay, so let me check the dot product. Vector A into vector B is given by AX BX plus AY BY plus AZ BZ under the square root. Okay, how to find the dot product? The dot product of vector A and vector B is given by AX BX plus AY BY plus AZ BZ. What is the data given to me? Vector A is equal to 2i cap plus j cap plus 2k cap, and vector B is equal to 2i cap minus 2j cap minus k cap. Please note, this 2 is AX, this 1 is AY, this 2 is AZ. Similarly, for B you have BX, BY and BZ. The coordinates of I cap, j cap and z cap. So I have, this is 2 into 2 plus AY is 1, BY is minus 2, 1 into minus 2 plus 2 into minus 1. This is 4 minus 2 minus 2. This is 0. So once the dot product of the vectors is 0, I can conclude that vector A is perpendicular to vector B. Okay, we are starting off with very simple problems. Let us check the next problem. A constant force of 8 Newton is applied to a body which displaces the body through a distance of 9 meter in the direction of the applied force. Find the work done. What is the data? Force is 8 Newton and the distance travelled or the body is displaced by 9 meter. What do we know? We know that work done is a product of force and displacement. Force is 8 Newton, displacement is 9 meter. So work done is 72 joules. Please remember, the unit for work done is joules. Let us have a look at the next problem. The data given to me says an object of mass 10 kg is moving with a speed of 5 meter per second. Estimate the kinetic energy associated with the object. What is the data? Mass is 10 kg. Velocity is 5 meter per second. What do we know? We know that kinetic energy is given by half mv squared. Let me substitute for mass and velocity. So this is half into mass is 10 kg, velocity is 5. So this is 5 square. 2 ones are 2 5s are. So 5 into 5 into 5, this gives me 125. the kinetic energy is 125 joules. Let us check another problem. A force A which is given by 5 I cap, force A is given by 5 I cap plus 3 J cap plus 2 K cap. Okay. This force is applied over a particle which displaces it from its origin to point B. This point B is given by the vector 2I cap minus J cap. Calculate the work done on the particle. We know that work done is given by the scalar product of force and displacement, which is nothing but A and B in this case. So how do I get the scalar product or the dot product? A dot B is given by AX BX plus AY BY plus AZ BZ. Okay. What is AX? It is 5. What is BX? It is 2 plus AY is 3. BY is minus 1. AZ is 2. BZ is 0. So this is 10 minus 3. So work done is 7 joules. Let us check one more numerical. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube. So volume of the tank equals 30 meter cube. What is the time required? It says that this pump can fill the tank in 15 minutes. Please remember, we always want time to be in seconds. So 15 into 60, which is 900 seconds. So the tank is filled in 900 seconds. If the tank is 40 meter above the ground, so the height of the tank above the ground is 40 meters. Efficiency of the pump is 30%. Okay, this is a new terminology. Efficiency is given by eta, which is 30%. What is efficiency? Efficiency is nothing but output by input. Whatever is the input given to it and what is the output that you are getting. We will come to that point later. Okay. Now what is the question? He has asked me to find out how much power is consumed by the pump. What is the power consumed by the pump? Now let us get to it step by step. What is the first data? The data is volume is given to me. Please remember, for any of the calculations we require mass. What is the relation between mass and volume? I know that density equals mass by volume, or mass is equal to density into volume. The data given to me says density of water is 1000 kg per meter cube. So this is 1000 into volume is 30. So mass is equal to 30,000 kg. We know that power is given by work done by time taken. What is the work done here? The work done is lifting the water into the tank. Okay. So this work done is nothing but mgh by T. Mass into gravitational force into height up to which the water is lifted divided by the time taken. Okay. So what do I have? I have power output. This is power output because this is the work that is being done by the pump. So power output is mass is 30,000 kg into gravitational force is 9.8, height is 40 meter, divided by time taken is 900 seconds. Use your simple calculator and let me know what is the power output. This is 13,066 watts. The output power of the pump is 13,066 watts. What is the question asked? It is not the power output. The question is, what is the power consumed by the pump? Okay. So that is why I said efficiency is power output by power input. Okay. I know that efficiency is 30%, or this is 0.3 is equal to, what is the power output? It is 30,066 divided by power input. Cross multiply and find out what is the power input. Use your simple calculator. The power input is 43.556 kilowatts. The power consumed by the pump to lift 30 meter cube of water to a height of 40 meter in a time interval of 900 seconds is 43 kilowatts. Let us have a look at one more problem. A man pushes a roller with a force of 50 Newton. A force of 50 Newton is applied on the roller through a distance of 20 meter. The displacement is 20 meter. Calculate the work done if the handle of the roller is inclined at an angle of 60 degree. Okay. So it says theta equals 60 degree. What do we know? We know that work done equals force into displacement into cos theta. This is 50 into 20 into cos 60. Please remember, cos 60 is half. Okay. So what do I have? I have work done equals 500 joules. Let us have a look at another problem. A body of mass 0.5 kg. So the mass is 0.5 kg. Travels in a straight line with a velocity v is equal to 5 into x to the power 3 by 2 meter per second. He has not directly given any velocity to me. He has given me an equation. Let me check. What is the work done by the net force? He has asked me to find out what is the work done. When the body travels from x is equal to 0 to x is equal to 2 meters. So initially it was at a position 0 and finally it has ended at a distance of 2 meter. Let me find out the initial and final velocities. At x is equal to 0, vi is equal to 5 into, in place of x I am putting a 0 to the power 3 by 2. So initial velocity is 0. At x is equal to 2 meters. Final velocity is equal to 5 into 2 power 3 by 2. Okay. I can write this as 10 root 2. Final velocity is 10 root 2 meter per second. I will not further solve this down because I will need this terminology. I will have to further use the calculator. Then I will be solving this further down. What do I know? I know that work done is equal to loss of kinetic energy or change in kinetic energy. This is final minus initial. What is kinetic energy final minus initial? I know that kinetic energy is given by half mv square. This is final velocity minus half mv square. This is initial velocity. What do I know about the velocities? Initial velocity is 0. So this entire term becomes 0. What am I left with? I am left with half m final velocity square. Let me substitute. This is half. Mass is 0.5 kg. Final velocity is 10 root 2. Please use your simple calculator and let me know what is the work done. The work done is 50 joules. Let me have a look at the next problem. A bullet of mass 100 gram So the mass is 100 gram, or this is 0.1 kg, is fired from a gun with a velocity of 432 km per hour. The initial velocity is 432 km per hour. Please note that we use meter per second as the unit for velocity. So please convert it. This becomes 120 meter per second. The bullet strikes a wooden plank and emerges out in 0.01 second. Time is 0.01 second, and it comes out with a velocity, the final velocity, 144 kilometer per hour. Once again, convert this into meter per second. This will be 40 meter per second. Okay, what should I find out? Calculate the work done by the bullet in penetrating the wooden plank and the thickness of the wooden plank. Okay, what do we know? From the work energy theorem, we know that work done by the bullet is nothing but the loss of kinetic energy. Whatever was the kinetic energy that was lost, okay, that will be equal to the work done by the bullet. What is loss of kinetic energy? This is initial kinetic energy minus final kinetic energy. What is this? This is half mvi square minus half mvf square. Let me substitute. This is half. Mass is 0.1 kg. Velocity is 120 minus half into 0.1 into 40. That is the final velocity square. Use your simple calculator and let me know what is the work done. Work done is 640 joules. This is the first part of the answer. Okay. What else is asked? He has asked me to find out what is the thickness of the wooden plank. We know that average velocity is equal to displacement by time. Please observe one concept here. What is the displacement? The displacement is nothing but the distance traveled by the bullet. The bullet emerges out of the wooden plank in 0.1 second. Okay. So the thickness of the wooden plank is nothing but the product of average velocity into the time taken by the bullet to come out of the wooden plank. What is the average velocity? It is 120 plus 40 by 2. The average of the two velocities into time taken by the bullet to come out is 0.01 second. Use your simple calculator and let me know what is the thickness. The thickness of the wooden plank is 0.8 meter. Let me have a look at the next problem. In a ballistic demonstration, a police officer fires a bullet of mass 50 grams. Okay. So the mass is 50 grams, or this is 0.05 kg. The velocity of the bullet is 200 meter per second. It is fired onto a soft plywood of thickness 2 centimeter. Okay. So plywood thickness is 2 centimeter, or this is 0.02 meter. The bullet comes out with a final velocity which is 10% of the initial velocity. Okay. So final velocity is 1/10 of the initial velocity. So this is 200 by 10, which is nothing but 20 meter per second. This is the final velocity. What is the emergent speed of the bullet? There is one more set of data given to me. What does it say? The bullet emerges with only 10% of the initial kinetic energy, which means that final kinetic energy is equal to 0.1 times the initial kinetic energy. He has asked me to find out the emergent speed of the bullet or the final velocity of the bullet. V final is what I have to find out. Let me find out the initial kinetic energy. Kinetic energy is given by half mv square, the initial velocity. So this is half, mass is 0.05 into velocity is 200. Use your simple calculator and let me know what is the initial kinetic energy. The initial kinetic energy is 1000 joules. What do I know? I know that final kinetic energy is 10% of initial kinetic energy, which means to say that the final kinetic energy is 100 joules. What is the formula for kinetic energy? Kinetic energy is given by half mv square. I have already found out the initial kinetic energy. Final kinetic energy is given by final velocity. Okay, that is what I am supposed to find out. What is the emerging speed of the bullet? Let me check that. Vf square equals 2 kf by m, or final velocity is equal to square root of 2 times the final kinetic energy by the mass. On substituting, I get it as square root of 2 into final kinetic energy is 100 joules divided by mass is 0.05. Use your simple calculator and let me know the final velocity. The final velocity is 63.2 meter per second. So the bullet emerges out of the soft plywood block at a speed of 63.2 meter per second. Let us have a check at one final problem. This is more to do with your day-to-day activities. You can calculate the power consumed by each and every electrical equipment. Let us check. A 100-watt bulb. So power is 100 watt. Is switched on for 10 hours. Time is 10 hours. Calculate the energy consumed. What is the energy consumed? In kilowatt hour. Why have I used kilowatt hour? Because that is the unit on your energy meter at your house provided by the electricity board. There is a small hint given. To find energy in kilowatt hour, power must be in kilowatt, time must be in hours. Power, he says, is 100 watts. So this is nothing but 0.1 kilowatt. Time is already in hours. What do we know? We know that power is energy spent over a period of time, or the energy is equal to power into time. This is nothing but 0.1 into 10. So the energy consumed is 1 kilowatt hour. If you switch on a 100-watt bulb for 10 hours, the power consumed is 1 kilowatt hour, what we generally call as 1 unit. Okay, have a wonderful learning experience. Thank you.